All right, let's pull back the curtain on the invisible engines that power pretty much everything you do online. Seriously, from the apps on your phone to the biggest websites in the world, they all run on one thing: databases. And today, we're going to break it all down.
Have you ever stopped to think about it? How does your social media app remember every single friend you have, every post you've ever liked? Or how does your bank keep a flawless record of every transaction? It really feels like magic, doesn't it? But it's not.
The answer to all of that is the same thing every time: a database. All that information for literally millions of users is stored, organized, and managed inside what's basically the digital brain of the modern internet.
So what are we really talking about when we say database? Let's get into the big idea and break down the core pieces, starting from the very beginning.
It all starts with this: data. Now notice the key words here: raw, unorganized, a single number, a name, a photo. On its own, it's just a lonely piece of information. The real magic happens when we give it some structure.
And that's exactly where the database comes in. It takes all that raw data and puts it into an organized system. I love this digital library analogy because it's spot on. A database isn't just a random pile of books. It's a library with shelves, categories, and a card catalog, all designed so you can find exactly what you need, like instantly.
But, how do you actually use that library? You can't just walk in and start shouting for books, right? You need a librarian. And in the tech world, that's the Database Management System, or DBMS. This is the actual software, like MySQL, which we'll get to in a sec, that handles all your requests, manages security, and just makes sure everything runs smoothly. It's the gatekeeper, the guide, the whole shebang.
Now, it's important to know that not all databases are built the same way. In the world of data, there's kind of this fundamental split between two main philosophies, two different flavors, if you will: SQL and NoSQL. And this table really lays out the big difference. So on one hand, you've got your relational databases, which use SQL. Think of these like super organized spreadsheets with strict columns and rows. They're perfect for structured data where consistency is everything, like say bank transactions. On the other side, you've got NoSQL. These are way more flexible, more dynamic. They're built to handle massive amounts of different kinds of unstructured data. Like all the different posts, images, and videos you see on a social media feed.
So for the rest of our time here, we're going to focus on that relational world, and specifically on one of its absolute biggest players, MySQL. This thing is a true workhorse of the internet. We're talking about the original systems for giants like Facebook, Google, and Twitter. They were all built on MySQL. It can handle just insane scale, which is why it's the go-to for so many web applications.
So, what's the secret sauce? What makes it so popular? Well, first off, it's open source, which means it's free to use. It's also known for being incredibly fast and high performance. It's scalable, so it can grow with you from a tiny blog to a massive enterprise application. It's got rock-solid security. And then there's this term, ACID compliant. Just think of a bank transfer. Money has to leave your account and arrive in the other one. It can't just do one and not the other, right? ACID compliance is a guarantee that data transactions are all or nothing, which ensures total reliability. It's a huge deal.
Okay, so we've got our database concept, and we've got our DBMS, which is MySQL. How do we actually talk to it? Well, we use a special language designed just for this: SQL, which stands for Structured Query Language.
The very first thing you do is create the main container for all your data. Think of this command as laying the foundation for our digital library. With one simple line of code, we create the entire database that's going to hold all of our tables and all our information.
Okay, now that we have our database, we need to build the shelves inside it. We do that by creating tables. This command here, for example, makes a table called employee. But look closer. It's also creating the blueprint for our data. We're telling it, hey, I need an ID column that's a number, and it should automatically go up by 1 for each new person. That gives everyone a unique ID. And we're also creating a name column that holds text. This structure is what makes these relational databases so powerful.
So our library is built, the shelves are in place. Now it's time to actually manage the books, or in our case, the data. And this really boils down to 4 fundamental operations that you'll hear developers call CRUD.
CRUD is an acronym, and it stands for Create, Read, Update, and Delete. Pretty much everything you could ever want to do with data fits into one of these 4 categories. It's the absolute bread and butter of database management, so let's take a quick look at the SQL for each one.
First up, create, which uses the insert command. This is how we add a new row,
or a new record into a table. Anytime you sign up for a new service or post a comment online, you can bet a command that looks almost exactly like this is running in the background.
Next is read, and this is handled by the select statement. This is, without a doubt, the most used command in all of SQL. It's how you ask the database to give you information. That little asterisk is just a wildcard that means give me all the columns. So this simple command is asking to see every single piece of data in the table.
Now we have update. What if you need to change something that's already there, like when a user updates their email address? You use the update command. But, and this is crucial, look at that where clause at the end. That part specifies exactly which record to change. If you forget it, you will update every single row in the entire table. Not good.
And finally, we have delete. And just like with update, that where clause is absolutely critical. It is the only thing standing between deleting one specific user account and accidentally wiping out your entire user base. You have got to be specific about what you want to remove.
So we've covered how to manage individual records one by one. But the true power of SQL isn't just about storing data. It's about asking it really complex questions to unlock powerful insights.
So instead of just pulling out a giant raw list of everyone, SQL lets you perform calculations on your data using things called aggregate functions. You're no longer asking for all the employees, you're asking for a summary. You're asking for the total number of employees, one single meaningful answer.
And this is how you do it. The count function does exactly what it sounds like. It just counts the number of rows that match what you're looking for. In this case, count star counts every single row in the employee table, giving you that total number instantly. Simple, but so powerful.
And here's another incredibly cool feature, the join. See, to keep data clean, you don't just dump everything into one giant table. You might have one table for employees and a totally separate one for departments. A join is the command that lets you temporarily link those tables together based on a shared ID. This lets you ask much more interesting questions, like, show me the names of all employees who work in the engineering department, and it pulls the answer from both tables at once. From social media and e-commerce to AI and data science, databases are the unseen foundation of our entire digital world. They store, protect, and connect the information that runs our modern lives. We've seen how they're built and how we can talk to them, so the only question left is the one right there on your screen. Knowing just how powerful they are, what are we going to build with them next?